Google has officially announced on 23 October 2019 that it's achieved quantum supremacy in a new article published in the scientific journal Nature. The announcement comes exactly 1 month after it initially leaked, when Google's paper was accidentally published early. Now, however, it's official, meaning the full details of the research are public, and the broader scientific community can fully scrutinize what Google says it's achieved. The quantum supremacy experiment was run on a fully programmable 54-qubit processor named Sycamore. It's comprised of a two-dimensional grid, where each qubit is connected to 4 other qubits. As a consequence, the chip has enough connectivity that the qubit states quickly interact throughout the entire processor, making the overall state impossible to emulate efficiently with a classical computer. Google says that its 54-qubit Sycamore processor was able to perform a calculation in 200 seconds that would have taken the world's most powerful supercomputer 10,000 years. That would mean the calculation, which involved generated random numbers, is essentially impossible on a traditional, non-quantum computer. 6 years ago in 2012 it has been proposed by John Philip Preskill. John Philip Preskill is an American theoretical physicist and the Richard P. Feynman Professor of Theoretical Physics at the California Institute of Technology. He described the point where quantum computers can do things that classical computers can't. This threshold has not been met. How it works: a classical computer carry out logical operations using the definite position of a physical state. These are usually binary, meaning its operations are based on one of 2 positions. A single state, such as on or off, up or down, 1 or 0, is called a bit. Quantum computers perform calculations based on the probability of an object state before it is measured, instead of just ones or zeros, which means they have the potential to process exponentially more data compared to classical computers. In quantum computing, operations instead use the quantum state of an object to produce what's known as a qubit. These states are the undefined properties of an object before they've been detected, such as the spin of an electron or the polarization of a photon. IBM says about the Google's quantum supremacy that we argue that an ideal simulation of the same task can be performed on a classical system in 2.5 days and with far greater fidelity. Building quantum systems is a feat of science and engineering, and benchmarking them is a formidable challenge. Google's experiment is an excellent demonstration of the progress in superconducting-based quantum computing, showing state-of-the-art gate fidelities on a 53-qubit device, but it should not be viewed as proof that quantum computers are supreme over classical computers. Significant of quantum supremacy: Google now have the first widely useful quantum algorithm for computer science applications, certifiable quantum randomness. Randomness is an important resource in computer science, and quantum randomness is the gold standard, especially if the numbers can be self-checked, certified to come from a quantum computer. Testing of this algorithm is ongoing, and in the coming months we plan to implement it in a prototype that can provide certifiable random numbers. Like, share, and subscribe. And don't forget to hit bell icon.